right, now the purpose of this experiment is to see how different molecules will attract to each other. So we have a substance here, which is acetone, or commonly known as your nail polish remover. We have regular water here, and then we have a salt, okay? A salt which is an ionic compound. Now we are going to combine these and see if there are any intermolecular attractions, intermolecular forces attracting them together to combine. Now, first we're going to start with acetone and water. Now, we do have a problem with acetone and water because they're both clear liquid solutions. So when we combine them, it's going to be very difficult to see if there are any attractions between the two. So we need to kind of figure out a way to differentiate between this clear liquid solution, which is acetone, and this clear liquid solution, which is water. And so what we're gonna need to do is to add a color to each one of these. So that way we can distinguish the acetone from the water. Now, it so happens to be that blue glitter will actually attach to the acetone really well. So we're gonna combine acetone and blue glitter so that the blue dye will stick to the acetone. That way the blue colored solution is acetone. It will stick to it really, really well. And for water, happens to be that yellow food coloring. The yellow food dye will actually attach to water molecules really, really well. And so this is gonna be a good indication that the yellow solution is gonna be water. It's just gonna be yellow colored water, and this is gonna be blue acetone solution. So once we achieve this, then when we mix them, we should be able to see if there's any interactions between acetone and water. If there is, we should see the colors mix. So which color would you predict if we have blue and yellow combined, if there is interactions between these two? Now, obviously, if there is no interactions, well then, they are gonna be separate from each other. We should see a blue and a yellow separate from each other. So we're gonna go ahead and do this and see what we get. Once we have achieved that, then the next step is to add salt to it. Okay, salt is an ionic compound, it's a metal, non-metal, and we are going to go ahead and add that into this mixture. Now, what we want to see is if the salt will actually bind or combine through these intermolecular attractions to either the water or the acetone, if it either combines to either of them, or if the acetone and the water prefer to stay combined. So if they prefer to stay combined, we should continue to see a greenish, dark brownish solution, which is the combination of yellow and blue. However, if the salt does prefer to attach and has stronger forces of attraction to either water or acetone, then when that combination occurs, then it's gonna boot out the other one away, and we should see a separation of colors because this is taking preference in terms of intermolecular attractions to one or the other. So the goal of this experiment is to see the intermolecular preferences between these three, and if there's any preferences. If there's not, we should see a separation from the beginning between the acetone and the water, or if there is, we should see some type of combination, and when we add the salt, we should be able to see a preference for salt to one of these and another separation of colors because it prefers the salt versus the other substance, and they should be able to separate.
Wait, you loaded. Wait, you loaded. Wait, you loaded. Wow. Wait, you loaded.
Now that you know that salt has selected water or acetone, which one do you think it actually preferred? Think about the Lewis structure, and when it dissolves, we know it's a metal, non-metal that are charged particles. Which of these two substances would turn out to have an attraction due to its charges?